Separation of variables. It is an integration technique for differential equations. We will look at the definition and then solve a problem. So the definition is dy dx is equal to a function of x times a function of y. And the goal is to separate these two functions. So we have in terms of y on the left side and in terms of x on the right side. We can do so by divide by h of y on both sides, and then these cancels on the right side. We then have 1 over h of y dy dx is equal to g of x. If we now multiply by dx on both sides, then dx cancels on the left side, and we then have y of h of y dy is equal to g of x dx. We now have in terms of y on the left side and in terms of x on the right side. So now we are ready to integrate this little guy. And the problem that we will solve is x squared plus 1 dy dx minus x times y is equal to 0. All right, you ready? All right, so the problem that we have is x squared plus 1 dy dx minus x times y equals 0. So we need to rewrite this into the form of dy dx equals a function of x times a function of y. All right? So the first thing is we add the x times y to the right side. So then we have x squared plus 1 parenthesis close dy dx equals x times y. Alright, and then we can, after this, we're going to divide through by the x plus 1 on both sides. So x squared plus 1. Alright, what do we have there? Now we have dy dx equals x over x squared plus 1 times y. So now we have a function here of x, and we have a small little function in terms of y, even though it's just one lone little y there. Alright, so now we can just proceed to do one more thing. Okay, we want this x over on this side. So we then multiply by dx on this side and multiply by dx on this side. Okay? And then we're going to do one more thing. We can do it in one swoop. We divide through by the y. Divide through by y. Then these cancels. Then we have on this side, we have 1 over y dy. And on the right side, we have a function of x dx. So let me write that so it looks a little nicer. 1 over y dy equals then x over x squared plus 1 dx. Alright, now it's time to integrate this little puppy. Now this one integrated, so you should know by now it's a calculus 2 you're in, so 1 over y integrates to ln of y. Okay, but this one is a little trickier to do. Okay, we're going to have to do a u sub for here. U sub. I'm going to do that as an aside. Okay, so we're going to say let u equals the denominator x squared plus 1. Remember, when we take the u, we want to find the right side to become this x dx. So the derivative here is 2x dx, almost there. Divide through by 2, so then we have a 1/2 du equals x dx, and there we have it. Okay? So then this becomes then 1 over u times 1/2 du. Right? This integrates also to a logarithm. So what we have now, we have ln of y equals 1/2 ln of u. Since there's no limits in the integrand, we have to add a constant, and I will call that constant C1. Okay? Now, to get the y out, because we want, in the end, we want the functions to be equal y something, okay? So get the y out of it, and ln. Remember, we can raise it both sides to the power with e as the base. So then we have e times to the power of ln of y equals then this whole chunk. E, first one thing to remember when for the properties of logarithms, the coefficient here, the constant here, is the same as writing that to the power up here. So I'm doing that right away. Okay, so then we have e, and what do we have then? We have ln of u to the power of 1/2 plus c1, that constant. All right. Now, if you remember from the properties of logarithms, e to the power of ln brings out the variable. Okay, so now we have y equals, and I'm going to split this up. Remember, when you adding, you see added exponents is the same as multiplying the bases. So what we have, e to the ln of u to the 1/2 times e to the power of that c1. Now remember, this is a number. E is just a number, 2.71 and some decimals, and this is just a constant. So this is a constant. Okay? And this one I will label C2 because it's not the same constant. And what comes out here, we have the same properties as we did here. The u to the power of 1/2 comes out. So now we have y equals u to the power of 1/2 times C2. And remember, this is u. So what do we have in the end? We have y equals x squared plus 1 to the power of 1/2 times that constant C2. I like to keep my roots as power, but if you don't like that, actually I'm going to box this one now because this is a valid answer. But if you like to you prefer to write it out with the square root sign, then by all means go ahead and do so. Voila, there you go. Alright, so the trick is with these ones is to recognize when you have x times y. Whenever you see something like that, you use separation of variables. Alright, that's it. I hope this was useful, and thanks for watching. Bye.